How many three-digit numbers have the product of their digits equal to 6? So three numbers multiplied together to give 6. Well, one option would be 1, 2, and then 3. So they're all different. Because the prime factorization of 6 is 2 times 3 after all. Now there is another option, and that is to use 1 twice, and then a 6. And that is it. That's all there's going to be, except we can arrange the digits. So there's actually 6 ways to arrange 1, 2, 3. There's a multitude of different ways that you can show this. You might know that when you have 3 distinct objects, there are 3 factorial ways of arranging them. Actually, this comes from the fact that there's 3 ways to arrange the first one, and then 2 to put in here because we're not repeating them, and then 1 to put in here. So we get 3 times 2 times 1. You can, of course, just systematically list them if you prefer. So let's write all the ones down that start with 1, and then all the ones down that start with 2, and then 3. So in which we see there's 6. This leaves us with 116. How many different ways to arrange this? Okay, now probably the quickest way to do this is to just say how many different ways, well, I'm just going to actually list them. So the 6 could go last, or it could go second, or it could go first. So there's actually 3 ways to arrange this one, and therefore 9 in total. Now, a bit more on this. You could treat it like the previous one, 3 times 2 times 1 to arrange 3 things, but account for the fact that we are now double counting. If I swap those two ones around, we'll get the same configuration. So 3 times 2 times 1, actually, but then I need to divide by 2. There is also a way to do it, which is essentially this. If you have, say, A, B, B, C, then this would be 4 factorial, but we would divide, actually I'm putting another B in, I think. This would become 5 factorial, but then we would divide by 3 factorial because there are 5 objects, but within each arrangement we could rearrange the B's in 3 factorial different ways. Okay, so you may have covered that, may have not have, but in any case, the answer is 3, and so overall it's 9.